Hi all, just a quick video to help you with problem number 1 on Tech Project for Chapter 5. In this problem we're going to simulate rolling a die using the die simulator application from the StatSims folder. So I'll go ahead and open that up real quick. So let's see, do I have that folder out? Yep, so we'll double click on the die simulator, pull that in. Part A says to enter your name, so do your name here. Make sure you type that in first thing. Then it says to change the number of rolls to 600. And I never like to give you the exact same numbers, so I'm going to do 1500, show you what I would do with that. And you'll do very similar stuff with yours, but that way you're just thinking about the theory and not just getting an answer from me. Alright, so let me go ahead and go back to the direction sheet. And I believe we've taken care of part A. We entered our name, we did the sample size. Again, I'm doing 1500 there instead of 6, but the same idea. And then they want us to answer a couple questions before we get started with the simulation. So if this is a fair die, then what would you expect the count to be for each number after you finish your 1500 rolls? So I'm just going to bring the calculator in here. If it's a fair die, then all 6 sides should be equally likely to be the one that shows. So if I take 1500 and divide that equally among the 6 numbers, then each number should show up 250 times. So that's probably not exactly what's going to happen, but theoretically that's what would happen on a fair die. So we'll come over here and we'll type that in. So I expect each number to show up about 250 times. And you can show the work on that or not. That's not really a big deal to me. If you're going to show the work, I guess we'd say 1500 divided by 6. That's not the only way to think of it. There's other ways to still get to the same answer, but that's one of the easy ones that people come up with a lot of the time. Alright, so that's how many. The second question says if it was a fair die, then what would the percentage be? So let's pull the calculator back in. If we got 250 for each number out of 1500 rolls for each number, then that would be 0.16 repeating, and move the decimal over a couple spots, do our rounding. That should be about 16.67%. So back to my report. So I expect each number to show up about 16.67% of the time. I think the word about is important because this is a simulation of a random event, so we can't predict exactly what's going to happen, but we would think this is roughly what would happen. Alright, so let's see what part D asks us to do. What shape would you expect for that? So I'm going to let you answer that. I'm not too worried about whether you get it right or not. I do just want you to think about it later on. So somewhere down here, it's going to ask you about the shape. There it is. Did the 2 histograms take on the shape you predicted in D? So I'll let you think about that. I do want you to answer B, C, and D before you watch any more of this video, because I'm going to start running the simulation, and I think it's important that you think about how these things would turn out before you see the result. So if you haven't answered these yet, please pause the video, try and answer those 3 questions, and then come back and watch the rest. Alright, so let's see, jumping back in, we're going to start rolling the dice now and see what happens. So we're going to click it a few times to get a feel for what the program does, and then we'll click automatic to finish off all the rolls. So let me pull that program back up. So if I roll it once, the die came up a 3, so I see the count go to 1 in that spot, and so far it's been 100% 3s after 1 roll. I do it again, I got a 3 again, so it's still 100% 3, 2 times now. You also see that the graph is showing that 3 is the only thing that has happened so far. And now a 6, so now we have another one, and our percentage is starting to spread out. 33% here, 67% over there, and we're seeing other things show up on the graph. So as you keep getting different numbers, it's going to keep updating those statistics. If you click automatic, it'll roll through all of them. So it doesn't take too long, hopefully, to roll the 1500. So we'll let that finish off. We'll capture that screen into our report, and we'll think about the other questions. So again, yours is going to be a little different because you set yours to 600 and I'm doing 1500, but it'll be the same idea. Alright, and then we'll slow down for drama there, and it's finished. So I just want to use Alt Print Screen to capture this. Just a reminder, when I press Alt, this is most likely going to disappear. Here goes Alt, yep, and there it goes. We need that graph because it's referred to in later questions. So we should click redraw if that happens and try it again. So let me try Alt again, and it stayed. So I'm holding down Alt and I'm pressing print screen. That's copy for this window. I can go to my report, and actually let me just check the directions real quick. It was part F that asked me to put that into the report. So I'll go to F, and I always like to get on a fresh line when I'm going to enter a graph, and Control V to paste that in. A little close to the margin, so we can resize that, make it a little smaller, no problem. Just make sure all the numbers remain readable. And there we go. And this one you do need to answer, but I'm going to leave that up to you to think about. And let's check on the directions and see where we are. We just did our Alt print screen and put that into our report. So part G, which of the numbers counts was furthest away from you expected, and how far was it off by? Alright, so we expected 250. Right, that's what we said. So this one missed by 7, this one missed by 2, this one missed by 13. Just taking the difference between 250 and these numbers, this missed by 4, 15, and 3. It looks like 265 is the count that's furthest off from 250. But 265 is not the answer to the question. They said which number showed up furthest from expected. They mean which number on the die. So that would be the number 5 because it was off by 15. So it showed up 265 times, which is 15 away from the 250. So that was the furthest. This one was kind of close with the number 3. It was off by 13. You shouldn't be concerned with whether it was over or under. They just asked which was the furthest away, so that would be the one. And then the next question is about the percentage, but it's the same thing. So which number's percent was the furthest away from expected, and how much was it off by? So for that one, it turns out, a little spoiler here, it's always going to be the same number. So the two that are the furthest off are going to be 3 and 5, just like last time. And if I bring the calculator in here, we're expecting about 16.67%. So if you take 16.67 and you subtract the 15.80, that one is off by 0.87%, but I said this one will be the most unusual. Let's check that. 17.67% minus 16.67. That looks like that's going to just be an even 1%. So that was off by 1%. So that's going to be different for you because it's random. All your numbers will be different. It could be different which one it turns out to be, but that's the idea, is just to look at how far each of these percentages are away from the 16.67 that we predicted, and then see whichever one is the furthest, and then call out that number, which again is the number 5. So it was off by 1.00%. If you want to show me the work, that'd be great. I'd probably just glance at it on your paper and verify that it was off by what you're saying. But either way, show the work or calculate it off to the side. It doesn't bother me either way. All right, and then click clear, and let's do it again with a bigger number. All right, so they want us to go back to the simulator and click clear, which will get rid of all of our results, and then say, what if we did it for 600,000? And I'm not going to do this one for you, but I do want to just talk about the first thing they ask with that, which is, if we change that to 600,000, how if at all does that change the expected counts in percents? So you do need to answer that. So I would just suggest that you do something like, the expected count is now, and then put something in there, and expected percent is now, and put something in there. So maybe they'll change, maybe they won't, but I think the easiest way to talk about it is just to say, what would you expect? So if it was a 600,000 instead of the 600 you did already, or the 1,500 I did already, how's that going to change things? And if you think about it, it's got to change it somehow, right? You can't expect each number to still come up 250 times, because if that was the case, it would add up to 1,500, not 600,000. So there's going to be some changes there. But again, I'm going to leave it up to you to figure out what those would be. And I'm going to leave it up to you to go ahead and figure out the remaining questions. But hopefully this gets you off to a good start. So good luck with number 1, and there will be a video for the next one as well.